This is the last unit for college algebra, unit 4. Here we go. For all these problems in the entire review and the test, you're going to want your unit circle your unit circle formula sheet out. So please have that handy for when you're doing these problems. First, we start off with the inverse trig functions. The cosine of 5 pi over 6. The cosine is the x value, so that's going to be negative root 3 over 2. Then we do the inverse sine of that number. So we're looking for the y value, where sine is negative root 3 over 2. Since we're doing the inverse sine, we want only the right side of the unit circle. That would give us 5 pi over 3. However, because we can't go around the unit circle to get to 5 pi over 3, we have to go backwards. So when you go backwards on the unit circle, this becomes negative pi over 3. That's your answer. Number 2, the inverse cosine of root 3 over 2. For the inverse cosine, you can only use the top half of the unit circle. We're looking for the x value, which is at pi over 6. The tangent of pi over 6. The tangent of pi over 6 is the y divided by the x, which is going to be 1/2 divided by root 3 over 2. To fix this, we're going to multiply by the reciprocal of the denominator's fraction. All these things cancel, including the 2's. So we have 1 over root 3. Since we can't keep it like that, we're going to multiply by root 3 on the top and the bottom, which gives us square root of 3 over 3. Number 3, the inverse tangent of 1. Since we're doing the inverse tangent is only using the right side of the unit circle. Okay, we're going to see tangent at 1 where it is pi over 4, where you have root 2 over 2 divided by root 2 over 2. Put the rest of the stuff down. Okay, next, the cosine of pi over 4 is the x term, which is root 2 over 2. And now the inverse sine of root 2 over 2, again, we're looking for only the right side of the unit circle because it's the inverse sine, and that would be at pi over 4. Lastly, here we go. The tangent of 5 pi over 4 is going to be negative root 2 over 2 divided by negative root 2 over 2, which just gives you positive 1. Now we do the inverse sine of positive 1. We can only use the right side of the unit circle. So positive 1 is found as a y value at pi over 2 on the right side of the unit circle. We do the cosine of pi over 2. Cosine of pi over 2 is 0. Solving trig equations. Okay, to solve these, we have to get the trig function by itself. I'm going to subtract 5 sine of x to both sides, which gives me the square root of 3 is equal to 3 minus 5 is negative 2 sine of x. Since we're multiplying negative 2 times sine, I'm going to divide by negative 2 on both sides. So I have sine of x equals negative root 3 over 2. Now to find all the places on the unit circle where the y value is negative root 3 over 2, there are 2 of them, at 4 pi over 3 and at 5 pi over 3. Question number 6. In this case, we have to divide both sides by 4 first. That cancels out, so we have cosine square root of x equals 3 over 4. Now to get rid of the squared part, we're going to square root both sides of the equation. The squared and squared would go away. So cosine of x is equal to. We were going to break up the fraction with each having its own square root. So the top would be the square root of 3. That does not change. At the bottom, the square root of 4 is just 2. And since we took the square root of both sides of our equation, we have to put plus or minus. Now we have to find where the x value on the unit circle is either positive or negative root 3 over 2, which is, there's 4 of them. There's pi over 6, there's 5 pi over 6, there's 7 pi over 6, and 11 pi over 6. Number 7. This is one of the factoring problems. Again, as I mentioned before during the notes, you can make this 2x squared plus x minus 1 if you'd like to factor that instead of with the cosines and then put the cosines in later. That would work. I'm not going to, but it could work. I'm going to put 2 cosine here and cosine there. 2 cosine times cosine is 2 cosine squared. That's what this is. To get negative 1, I'm going to put 1 and 1. I just have to get my signs to work. I need a positive cosine here, which means this number has to be positive and this one has to be negative. So now I've set each one of my factors equal to 0 and then solve for x, solve for cosine. So cosine of x equals, I'm going to add 1 and divide by 2. And here I'm just going to subtract 1. So we're going to find a bunch of different stuff. So the cosine of x equals 1/2. Where's the x value equal to 1/2? That is at, it's got to be positive 1/2. That's at pi over 3 and 5 pi over 3. That's my first answer. Where's cosine equal negative 1? So the negative 1 is at pi. And those are my answers. Question 8. A little bit kind of like the last one we just did. I have to get all the stuff on one side, so I'm going to add sine to the other side. Now, 2 sine squared x and sine x are not like terms. One is being squared, one is not. So you're just going to write them next to each other. Now, because both terms have a sine in them, we're going to take the greatest common factor of sine out. Which leaves me 2 sine, not squared anymore, and sine divided by sine is 1. Okay, I take both factors, set them equal to 0. Now the first one's already done. So I'm going to find out what that is first. So the sine of x is 0. So where's the y value 0? There's actually 3 of these spots, 0, pi, and 2 pi. And then for the second one, I'm going to subtract 1 and divide it by 2. So where is the y value going to be negative 1/2? There's our 2 of those. They are 7 pi over 6 and 11 pi over 6. This one's taken directly, well, I think they're all taken directly from the practice. Here you're given a hint about what to do. I'm going to replace my cosine squared value with 1 minus sine squared. So I'm going to put 1 minus sine squared equals 2 sine of x plus 2. Okay, I'm going to move the stuff on the left to the right. So I'm going to subtract 1 and add sine squared x. All right, much like before, the 2 sine of x and the sine squared of x are not like terms. One is squared, one is not. So I'm going to just put them next to each other with the sine squared in front. Okay. Now we have a situation where we can factor this again. So I have sine x times sine of x gives me sine squared of x. The factors of 1 are 1 and 1. And they're both going to be positive. So they're the same thing. So I just take one of them, because they are the same thing, set it equal to 0. And now if I subtract 1 from both sides, I get sine of x equals -1. So to find out where the y value is -1 in the unit circle, there's only one of them. It is at 3 pi over 2. Number 10. So in this case, I'm going to leave the cosine where it is, and I'm going to add the square root to the other side so I don't have that negative sign anymore. Okay, so by putting it on the other side of my equal sign, I've added it, which means I get rid of that negative sign. Now I need to get rid of the square root sign. So I'm going to square both sides of my equation. When I do that, square root and square root cancel, and the cosine squared is on the left, and minus 3 cosine squared plus 1 is on the right. I am now going to add 3 cosine squared to both sides. So these, in this case, unlike some of the last problems we've just done, these are like terms. They're both being squared. So we have 1 plus 3 is 4, and that equals 1. Now to get cosine by itself, I'm going to divide both sides by 4. And to get rid of the squared, I'm going to square root. Squared and squared cancel out. So I'm left with cosine of x is equal to, now just like I did this kind of problem before, I'm going to break the fraction into two pieces, square rooting both of them. Square root of 1 is 1. The square root of 4 is 2. And because I put the square root on both sides of my equal sign, excuse me, I have plus or minus. Now, where is the x value? Positive and negative 1/2. Pi over 3. 2 pi over 3. 4 pi over 3. 5 pi over 3. Keeping it going. Okay, next, I'm going to add square root of 8 to both sides. I'm going to divide by -4. Now in this case, what we have is we have a square root, the square root of 8, that can be reduced. The square root of 8 is the square root of 4 times the square root of 2. Okay. The square root of 4 is just 2, and the square root of 2 is just left over. The 4 on the bottom does not change. It is still negative though. Now what we have, and we saw this with our tangent sum and difference problems, we have a fraction, 2 over 4, it's not in the square root, it can be reduced. So sine of x is equal to negative root 2 over 2. I'm going to find out where the y value is negative root 2 over 2 at 5 pi over 4 and at 7 pi over 4. To solve for tangent squared, so we're going to add 3. So 2 tangent squared equals -1 plus 3 is 2. Divide both sides by 2. You get tangent squared equals 1. Now because that's squared, we do have to square root both sides of our equation. Squared and square root go away. Left with tangent of x is equal to, the square root of 1 is 1. But because we took a square root of both sides of an equation, we have to put plus or minus. We want to know where all the parts of the unit circle, where tangent is positive or -1. They're all the pi over 4s, where you have root 2 divided by root 2. So we have pi over 4. We have 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, much like question number, where'd it go? 8. We're going to take a tangent out of both these terms. So the greatest common factor is tangent. We're left with tangent and 1. Okay, so we have tangent equals 0, and tangent plus 1 equals 0, since we take both factors and set them equal to 0. The first one is done for us, so we want to know where the tangent is going to be 0. That's a little bit trickier. There's only a couple spots. We want the y divided by x to give you 0. Well, that only happens in 3 locations: 0, pi, and 2 pi. All right, and then lastly over here, if we subtract 1, we want to know where tangent equals -1. There's only 2 of those. They happen at 3 pi over 4 and at 7 pi over 4. All right, so kind of like the problems we've seen before, we see that we have a sine and a sine. We're going to take the greatest common factor of sine out. We're left with 2 cosine plus root 3. Now that we have 2 separate factors, we're going to set both of them equal to 0. So we'll do the first one. We want to know where sine of x is going to be 0. So we're looking at the y values of our points. There's 3 locations: 0, pi, and 2 pi is where sine is 0. The second one, if we subtract root 3 and divide by 2, where's the x term going to be negative root 3 over 2? There are 2 of them: 5 pi over 6 and 7 pi over 6. And we're done with our equations. Last, we have some sum and difference identities. Oh, so beautiful. All right, here we go. So 5 pi over 12. We need to find 2 numbers that add up to be 5 that could be reducible with 12. I'm going to pick 3 pi over 12 plus 2 pi over 12. Since we're dealing with sine and we're adding, we're going to put it in the sign where you're adding equation on your formula sheet. So before I do that, though, I have to reduce these fractions. 3 over 12 is pi over 4, and 2 over 12 is pi over 6. So the sign and adding looks like this: sine of pi over 4, the cosine of pi over 6, plus the cosine of pi over 4, and the sine of pi over 6. So that's where all the pieces go into my equation from the formula and the problem. Okay, so now we've got to find all these values, what they are. So the sine of pi over 4 is root 2 over 2 on your unit circle. Cosine of pi over 6 is root 3 over 2. The cosine of pi over 4 is root 2 over 2. And the sine of pi over 6 is 1/2. So now we're just going to multiply the fractions together. Root 2 times root 3 is root 6. 2 times 2 is 4. On the other side, root 2 times 1 is root 2. And 2 times 2 is 4. Because these fractions have common denominators, we can add them together to get this. There's your answer. Now, just to let you know, everything I've done on the test, on the review sheet so far is the same kind of stuff I would do on the test, which is what you should do as well. All right, let's go to question 16. So we have negative pi over 12. Well, I'm going to do the same kind of idea. I'm going to do 2 pi over 12 minus 3 pi over 12. That'll give me -1. If I reduce those, I'll get pi over 6 and pi over 4. I'm doing the cosine with a minus. So the cosine with a minus looks like this. Cosine of x, which is pi over 6. And then cosine y, which is pi over 4. Minus, oh, sorry, no, I'm not doing that. I'm doing the minus one. It's going to be plus. Uh-oh. I hate when that happens. Sorry about that. Try going back to this. Lost my pen. Because we're subtracting, we are going to be adding based on our formula. Sine of pi over 6. And sine of pi over 4. So now we look at our values on the unit circle. Cosine of pi over 6 is the x value, so I have root 3 over 2. Cosine of pi over 4 is root 2 over 2. Plus the sine of pi over 6 is 1/2. Times the sine of pi over 4 is root 2 over 2. If I multiply these numbers together, I get square root of 6 on the top and 4 on the bottom. Square root of 2 on the top, 4 on the bottom. Since they have common denominators, root 6 plus root 2 over 4. Okie dokie. Next, negative 7 over 8. I gotta find two things that could be reduced using 8 as my denominator. Let's see here. This might be a typo. That might be from the half-life. So what we're going to do is we're going to make this a 12. Because we can't use 7 and 8. Because that doesn't work. Okay, so we're going to use 7 and 12. 7 over 12 instead of 7 over 8. It's a typo. My apologies. All right, but what we have is 2 pi over 12 minus 9 pi over 8. Oh, sorry, 9 pi over 12. Okay, that gives you negative 7. To reduce those, you get pi over 6 and minus, it's reducible by 3, so that's 3 over 4. 3 pi over 4. Okay, so since I'm doing sine and minus, do the sine of pi over 6, the cosine of 3 pi over 4, minus the cosine of pi over 6 times the sine of 3 pi over 4. All right, so the sine of pi over 6 is 1/2. Cosine of 3 pi over 4 is negative root 2 over 2. The cosine of pi over 6 is going to be root 3 over 2. The sine of 3 pi over 4 is root 2 over 2. So we get negative root 2 over 4 minus root 6 over 4. When you combine them together, you get negative root 2 minus root 6 over 4. Okay. Here we got 11. So we're going to do 5 pi. Nope, we're not. We're going to do 9 pi. Oh, we'll switch it up. We'll do 8 pi over 12 plus 3 pi over 12. Okay, we got reducible by 4, so we get 2 pi over 3 plus pi over 4. So cosine, we're adding. Looking at the cosine formula, we're adding. It's going to be cosine of 3 pi, 2 pi over 3. The cosine of pi over 4. Since we're adding, the formula has a subtraction. sine of 2 pi over 3 and the sine of pi over 4. So the cosine of 2 pi over 3 is negative 1/2. Cosine of pi over 4 is root 2 over 2. The sine of 2 pi over 3 is root 3 over 2. And the sine of pi over 4 is root 2 over 2. Goodness. Okay. Now negative 1 times root 2 is negative root 2 over 4 minus root 6 over 4 combined to give you negative 6. So negative root 2 minus root 6 all over 4. All right, we're almost done. 2 more questions. So we have 11 pi over 12. So I'm going to do 9 pi over 12 plus 2 pi over 12. Okay. So if I reduce those divided by 3, I get 3 pi over 4 plus pi over 6. Okay. Using the tangent formula, since I'm adding, I'm using the top signs in the formula. So I'm going to have tangent of 3 pi over 4. Top sign is plus. Tangent of pi over 6. On the bottom, I have 1. The top sign is negative. The tangent of pi over 3 pi over 4 times the tangent of pi over 6. So that's my first step. Okay, now I convert these. So 3 pi over 4 for tangent would be negative 1. For pi over 6, I'm going to do it over here. Yeah, do it right here. So pi over 6 for tangent is going to be y divided by x. Okay, I've seen this before. I did it at the very first question of the, the second question of our whole review. Let's go over here. Tangent of pi over 6 is right there. Okay, that's the work for it. And the answer I got was root 3 over 3. Okay. Let's go back down and just write positive root 3 over 3. On the bottom, we're going to have 1 minus negative 1 times root 3 over 3. Okay. So now, let's rewrite this with just simpler parts. Negative 1 plus root 3 over 3 divided by 1. The two negatives become positive and get multiplied by root 3 over 3 to just give you this. So now it becomes a lot of math stuff. We have fractions on the top and the bottom. We have to find the common denominator to combine the fractions. That would be 3. So we're going to have negative 3 over 3 plus root 3 over 3. On the top and the bottom, we're going to have positive 3 over 3 plus root 3 over 3. Okay, we're using 3 because that's the denominator of our fractional number. So the 3 over 3 is still equal 1. So we've changed the way it looks, but just not its value. Put an equals there. Next, if we combine those fractions with their common denominators, we're going to get negative 3 plus root 3 over 3 divided by 3 plus root 3 over 3. Now with complex fractions, like we did with the tangent of pi over 6, we have to multiply those by the reciprocal of our denominator. Okay, all this stuff will cancel, even the 3 is up there, but the other stuff won't. So we left with on the top, negative 3 plus root 3. On the bottom, 3 plus root 3. Now we still can't leave square roots in the bottom of our fractions. So we have to multiply by something. We're going to multiply by what we call the conjugate. Conjugate is the same terms in the denominator of your fraction with a different sign between them. Okay, and now we multiply everything out. Oops. So negative 3 times 3 is negative 9. Negative 3 times negative root 3 is positive 3 root 3. Next, root 3 times 3 is positive 3 root 3 again. And root 3 times negative root 3 is negative root 9. On the bottom, 3 times 3 is 9. 3 times negative root 3 is negative 3 root 3. Root 3 times 3 is positive 3 root 3. And root 3 times negative root 3 is negative root 9. Okay, now the root 9s both become just 3s. Now we can combine the terms on the top. Negative 9 plus 3, negative 9 minus 3 is negative 12. But 3 root 3 plus 3 root 3 is positive 6 root 3. You're just adding the numbers in front, using the square roots like a variable. On the bottom, 9 minus 3 is 6, and these two terms cancel each other out. Now, because those three numbers have a common denominator, or common multiple, sorry, they are reducible. So we're going to put down negative 2 plus root 3, because we reduced everything by 6. And that's your answer. And you're done. Last question. 7 pi over 12. I'm going to take 3 pi over 12 plus 4 pi over 12. Okay. So I reduce this to be pi over 4 and pi over 3. Oops. We're adding. Okay. So tangent adding again, we're going to use the top signs. So we do the tangent pi over 4 plus the tangent pi over 3. On the bottom we have 1 minus the tangent pi over 4 times the tangent pi over 3. Okay. Now we find on the circle what these are. Pi over 4 with tangent y divided by x will just give you 1, because it's root 2 over 2 divided by root 2 over 2. Pi over 3 is root 3 over 2 divided by 1/2. Oops. There we go. So we multiply by the reciprocal, like we did with pi over 6. All these cancel, including these 2's, which means I have scored a 3 left over. So that's what I'm going to put down here, plus root 3. On the bottom, 1 minus tangent of pi over 4 is 1. Tangent pi over 3 is root 3. So if I simplify this, I have 1 plus root 3 divided by 1 minus root 3. Now the good news about this particular problem is we don't have to combine fractions like we did in the previous problem. We can skip right to the conjugate. Same terms as the bottom with a different sign between the terms. 1 times 1 is 1. 1 times root 3 is root 3. Root 3 times 1 is again root 3. And root 3 times root 3 is root 9. On the bottom, 1 times 1 is 1. 1 times root 3 is root 3. Negative root 3 times 1 is negative root 3. And negative 3 times root 3 is negative root 9. The root 9's both becomes 3's. So I have 1 plus 3 is 4. And then the 2 root 3's become 2 root 3. On the bottom, the root 3's cancel. And 1 minus 3 is negative 2. Again, these terms are all common multiples, so we can reduce it by 2. So we're left with 2 I'm sorry, 4 divided by negative 2 is negative 2. And then 2 divided by negative 2 is negative root 3. And this is your answer. And that is the end of the review. So I wish you luck on your test. Good luck.